So, good morning to all of you. Today we are going to start the second unit of our course. It's about the transportation and assignment problems. So, we'll be studying about the transportation modeling. How do we model a transportation problem? Then we'll develop an initial basic feasible solution by using the various techniques such as northwest corner rule, row minimum method, column minimum method, the lowest cost method, and the Vogel approximation method. So these methods are actually used to find the initial basic feasible solution. But since the subject deals about the optimization techniques, so we'll also be learning about the various optimization methods which are used in to solve the transportation problems, such as the stepping stone method and the modified distribution method, which is also known as Modi method. Now, when we are solving the problems, we are actually considering that the demand and the supply for particular cases, for the numericals which we are going to solve, it is equal for them. But in certain cases, the demand and supply constraints, sometimes they are not equal. So in that scenario, we will also be looking for some numericals in which the demand and supply are not equal. So when we talk about the transportation modeling, what we are trying to we are actually looking for an interactive procedure that finds the least costly means of moving products from a series of sources to a series of destinations. That means we have a product that is available to us at one location, and we call that as a source, and we are trying to transport that product from the source to the different destinations. So the algorithm which can be used to minimize the cost, because our prime objective in solving the transportation problem is to minimize our transportation cost. So that is what we are trying to do here. Now it can also be used to help resolve distribution and location decisions, right? Like which city, like when you are considering the example of transportation problem, like that product has to reach the destination, but there are different warehouses in the between. So which warehouses it's going to be optimum in terms of cost. So this is what we are going to solve in this. So transportation problems are they can be seen as a special case of solving linear programming problems. We have been studying the linear programming methods like graphical method and simplex method, big M method. So which were studied in the unit number 1. So these can be seen as a special cases of linear programming. So what do we want to know before we proceed to solve any problem using the transportation methods? We need to know the origin points and the capacity or supply per period at each of these locations. Also, we should be very much clear about the destination points and what would be the demands per period at each of these destination points. Also, the cost of shipping of one unit from each origin to each destination. So these costs, they should be given to us like in advance, so that we can proceed and solve these problems. So here we see a transportation problem. So we have 3 different destinations: Jaipur, Nagpur, and Bhubaneswar, and we have like a product that is available to us at these 3 locations, and we want to transport that product to 3 different locations in Mumbai, Patna, and Lucknow. So these values of cost, they are giving us per unit cost for transportation. If I want to transport something from Jaipur to Mumbai, so the transportation cost per item would be approximately $5. So this is like a table which gives us the values of cost associated with various sources to destinations. So in the next page we'll be able to see like how this transportation model looks like. So this is the modeling of the transportation problem. So we can see that the Mumbai, Patna, and Lucknow. So we want to transport it to these points, and what are the sources that are available to us? We have Jaipur, which has 100 unit capacity. We have Nagpur that has 300 units capacity. We have Bhubaneswar that has 300 units of capacity. So the goods are to be transferred from these 3 locations to the Mumbai, Patna, and Lucknow. So what would be the algorithm, like how we'll be solving this problem so that the transportation cost is minimum in our case? So that we'll be seeing in the next page when we'll be forming the matrix. So in this slide, what we are seeing here is we are actually forming the transportation matrix We have been given the information about the various units which are available at the sources, and they have to be transported to the destinations. Also, we have been given the various values of cost. So we can see that in the previous table we have been given the cost for like from Jaipur to Mumbai, from Jaipur to Patna. So these values are cost allocations in every cell. And so warehouse requirement has been given for us for Mumbai, for Patna and for Lucknow as 300, 200 and 200 respectively. Now the factory capacity like how much the factory can have that product available. So it is 100 for Jaipur and 300 for Nagpur and 300 for Bhubaneswar. So when we talk about this cell, it actually represents a possible source to destination shipping assignment from Nagpur to Lucknow in our case. We can see by using this arrow. Also this value $7, it represents the cost of shipping 1 unit from Bhubaneswar to Patna. And this value, suppose if we are seeing this 200 value, this actually represents the Lucknow warehouse demand. Also when we solve these problems, we would want to make sure that the demand and the supply, it has to be equal. So we have to make a total of the units available at the sources and to the unit that needs to be available to the destination. So when we make a sum of these values, suppose 100 plus 300 plus 300, that comes out to be 700 for as in a factory capacity. And when we total the values for warehouse requirements, 300 plus 200 plus 200, so that also comes out to be 700. So we can see that this is a case of demand is equal to supply. So as we have seen on the previous slide, we were able to form a transportation matrix. So how that transportation matrix can be solved? So what are the various methods? So initially we are looking for a basic feasible solution by using the initial approach. So we could use northwest corner rule. So how do we proceed by using the northwest corner rule? First of all, we start with the corner of a matrix, right? So matrix, what was shown on the previous page, we start with the corner point from the left side, top left side. So what we'll be doing, we'll be exhausting the supply, the factory capacity of each row before moving down to the next row. Now the next step would be we'll be exhausting the warehouse requirements of each column before we'll be moving to the next column. So then we'll be checking that all the supplies of demands and supplies are met. That means the total value has to be, if supply has been utilized and there is some values left in demand, suppose supply is 200 and demand is 300, so we cannot neglect that. So that 100 value also has to be used. So this is how we are going to solve. So we'll see that on the next page. So these are some of the steps that we are going to apply while solving the problem using northwest corners rule. The number one is we will be assigning 100 units from Jaipur to Mumbai, because that is our extreme left corner, so that the Jaipur supply would be exhausted. Now the next step, we'll be assigning 200 units from Nagpur to Mumbai, and that would actually exhaust the Mumbai's demand. Then we'll assign 100 units from Nagpur to Patna. By doing so, we'll be exhausting the Nagpur supply. In the next step, we will be assigning the 100 units from Bhubaneswar to Patna. So that would result in exhausting Patna's demand. Now then we'll left with 200 units that we have to assign for Bhubaneswar to Lucknow, exhausting the Lucknow's demand from the Bhubaneswar. So we see that this is the matrix which was available to us. So first of all, I'll be starting with this value here, because this is the northwest corner cell method. So I told you that we'll be starting from this left cell, this corner left cell. So you can see that the factory capacity is 100 for it and warehouse requirement is 300 for it. So whichever is the minimum value, we have to allocate that to the cell. So we can see that if I compare 300 and 100, so I'll be allocating a value of 100 to this cell. So as soon as I have allocated a value of 100 to this cell, so this column would be eliminated. That means this column here, we put a cross line across this column, it would be eliminated. So now we can see that this warehouse requirement also has to be subtracted with 100 value, so that would make us a value of 200 availability here. So now the next cell for us, which is the corner cell, it is this Nagpur and Mumbai cell, which has a cost value of $8. So then I will have to check the demand and supply values correspondingly for this cell. I can see that the factory capacity, it's 300 here, and the warehouse requirement, after subtracting the 100 value, it was available to us as 200. So I know whichever is the least value, I have to allocate that to the cell. So I'll be allocating a value of 200 here. Since I am allocating 200 value here, so 200 minus 200, this warehouse requirement would become 0 here. Now the similar value of 200 has to be subtracted from the factory capacity here, so that would make it as 100, right? So the whole value for the warehouse requirement for this column would be eliminated, so we can put a cross around it. So now what is the next corner cell? The next corner cell is a cell which has a cost value of $4 here, and we remember that we had 100 value available from the factory capacity just before the previous calculation. So we'll be allocating that value 100 value here, and then this 100 value will be subtracted from this 200 value. So once you have allocated 100 value here, this row would be eliminated. Then this 100 value is available here and 300 value is available here. So minimum value is 100. So I'll be allocating a value of 100 here. So then I'll be subtracting a value of 100 from here. So that would make us a value of 200. So the next cell to it would be having a value of 200 here and 200 here. So the similar value can be allocated. Once as soon as you have done that, all the demand and the supply values have been utilized up. So we'll be seeing how we do the calculations to solve this problem. So we have done the iteration on the previous page. Now we are able to see that how the calculations can be made. So if you are able to recall that matrix, we had the route from D to A. Total number of units that were shipped needs to be shipped 100, and the cost per unit was $5. So we have to do the multiplication. So that was our first cell, the first corner cell on the left side. So we have allocated a value of 100, and the cost per unit cost for that product was $5, transportation cost. So we do the multiplication, it is 500. Similarly for the second cell, which was allocated in the previous matrix, 200 multiplied by 8, that comes out to be 1600. Now the next cell which we given the values of allocation, 100 multiplied by 4, it is 400. 100 multiplied by 7, similarly for the next iteration, 700, and then 200 multiplied by 5, that comes out to be 1,000. I'm sorry. So in order to calculate the transportation cost, we have to take the sum of all these values. So 500 plus 1600 plus 400 plus 700 plus 1000, that comes out to be 4200. So by using the approach of least cost method, corner cell method, we are able to calculate the value of transportation cost as 4200. So this is expected from the students that we have learned about one of the methods to find the initial basic feasible solution. So there are some assignment problems. It is requested from all of you that you should learn about how to formulate a transportation problem, right? Then you should also know that what are the constraints when we solve any problem using the transportation method. So what do you mean by constraints in that scenario? Also, it is expected from the students to discuss the significance of northwest corner rule of transportation, which we just have learned. So so these are some of the references which have been used in order to make these presentation slides. We have followed material from the book of Operation Research Hamdi Taha. Also some material have been used from the book Operation Research by R. Paneer Sullivan. Some of the diagrams have been used from the Operation Research book by J.K. Sharma. So it is recommended, and to all of you that you should also look for variety of numericals in these books. So I thank you all for attending this session, and I'll be looking forward to have more sessions of the similar kind, and we'll be learning more about the initial basic feasible solution other than what we have learned today, and we'll be looking for the optimization methods to minimize the transportation cost in these transportation models. Thank you so much.